Hey guys, in today's lesson, we're going to look at the last set of notes in Unit 8 on regression. Okay, so what is regression? Or let's talk about the fact that you've actually done a little bit before. I know it's been several years for many of you, but in Algebra 1, you learned about this thing called linear regression, and you found lines of best fit. You found a line of best fit. And so if you remember anything about Algebra 1, all right, what you did was you perhaps you either had to make one yourself, or maybe you were given a scatter plot, right? And that's just a bunch of ordered pairs that may or may not have some sort of relationship. And then you had to find the line of best fit, which was a line that went through as many points as possible. It's got to be a straight line though. But it has to go in the same direction of the points. All right, has about half the points above and below. And then you could use that line to make predictions. Okay, so whether you remember how to do that or not, that's okay, because I'm going to show you all the steps today. But we're going to be doing these regression lines for quadratic functions and exponential functions. And so quadratic, those we'll talk about what they are, refresh your memory on what that is in just a minute. But these are not lines, they're curves. So we're going to be finding curves of best fit. Okay, so quick refresher on the shape of these curves. All right, quadratic, those are your parabolas. Okay, so when you think about the shape, right, they either go down then up or up then down. Okay, but for exponential, that's one of the newest curves that we just learned about. We either start kind of small and then shoot up really sharply, or we start really big and then we kind of flatten out. Okay, so it's not both, it's one or the other. All right, and so it's important that we remember, what the standard form of each of these equations is. Because if we remember that, it's going to make doing this a lot easier. Okay, for quadratic, I'm talking about the fact that it comes from an equation like y equals ax squared plus bx plus c. Okay, that's quadratic. But for exponential, the standard form looks like this: a times b raised to the x. Okay, where a is a number, b is a number, and the exponent is x. All right, so the process of this is actually pretty easy because we're going to use Desmos to do it. It's just knowing the steps. Okay, so here's what I'm going to do. I am going to split my screen between Desmos and the notes here. And hopefully you can still see the notes, the directions for using Desmos. Maybe we can zoom in a little bit. Whoa, way too big. All right, how about, nope, still too big, sorry. Let's see if that'll fit. Not quite. Well, bummer. Okay, so there's not really much in between. What's 100%? Oh, that's good. Okay. All right, so the directions in Desmos. All right, so what you're going to be doing is you're going to be creating those scatter plots, a graph with dots on it in Desmos. And here's how you're going to do it. You have to add a table, and then you're going to fill in the values. All right, and so just be real careful when you do it that you don't make any mistakes. All right, so here's how you add a table. You click the plus symbol at the top of the expression list. So here we go. And then you choose table. There's a table. Now, this next thing is just a cautionary. When you're given values in years, you're going to have to make the first one 0 and then change the rest accordingly. And we'll talk about that when we get to an example. All right, so let's fill in a table. So let's go down here and look at number 1 so we can fill this table in. It says an amusement park ride takes riders to the top of a tower and drops them. The table below shows the height h of the tower at time t seconds after the drop. Okay, so in Desmos, your table is always going to be an x value and a y value. So you have to make sure that you understand that your table technically represents an x and a y value as well. Okay? All right, so in the x column, we're going to put in 0, 200, no, sorry, I'm just doing times first. 0, 0.5, 1, 1.5, and 2. And then, so those are all the times. And then in the y column, I'm going to put all the heights. 200, 164, 120, 68, and 8. Okay? Now, you actually can hide this at this point, right? And I don't know about you, but I don't see much. That's okay. Maybe I shouldn't have hit it yet. All right? Because the next step says, look at the scatter plot created, but it's hard to see it. So press the zoom fit icon to see the entire scatter plot. And that's this little magnifying glass with a plus sign on it. Then you can move your table out of the way. Okay, so you should see several green dots in this case. And it actually does kind of look like a line, but in this class, we're only going to do curves, okay? So you're going to have to decide if that looks more like a quadratic or more like an exponential. Well, it's okay if you're not sure. It's okay if you're not sure. You can actually check them both, okay? So what you're going to do in a new line, all right, is to check for quadratic, you have to literally, hold on. I want to change this to a highlighter real quick, and I don't think that did what I wanted. Nope, that's a crayon. Okay, you have to literally type either this equation or this equation. All right, so that is something you are going to have to know. All right, I don't like this. Okay, here we go. All right, so over here, I'm going to type in y, and then as I just hit the number 1, it'll automatically make it a little 1. All right, then I need this little tilde, and that's actually on your Chromebook keyboard. You have to hit Shift, and it should be the button next to the number 1. Let me see if it's on the keyboard. Okay, it is on the keyboard in Desmos. So if you open up the keyboard in Desmos, it's on the bottom row towards the right. Okay, so if you can't find it on your actual keyboard, you can use the Desmos keyboard. All right, and then we're literally gonna type A, and then X1, and then we're gonna raise it to the second, plus B X1 plus C. Okay. Why didn't that line up? Did I type something wrong? 0, 200, 1, 120, 1.5. It worked before. Hold on. Okay, I found my mistake. It's not plus 6, it's plus C. Ah, there we go. Okay, so it looks like that lines up pretty darn good. You can actually see that it goes through all of those points. So the likelihood of this being quadratic is very, very good. Now, just in case, if you want to check behind yourself, okay, if you want to check behind yourself, you can actually type in the other equation as well. Oops. That's going to be I'm having trouble here. And then put b in parentheses and raised to the x1. Okay? And so that's the one that I've drawn that has shown up here in black. And you can see that that definitely does not line up with the majority of the points. So that one is definitely not the right one. Okay? All right, so we can tell that this is quadratic. Now, once you have figured out which one it is, okay? All right, which one you figured out, once you figured out which one it is, you have to write down the equation that Desmos tells you, but you have to know what to look at, okay? So here's the one that worked that we said it was quadratic, and you are looking right here where it says A, B, and C, A, B, and C. And on your paper, you're going to literally write a quadratic equation, right? Remember we said that that was y equals ax squared plus bx plus c. You're going to write that down, but you're going to actually include the a, b, and c values that Desmos gives you. Okay? And so a is negative 16, so we're going to put that next to the x squared. B is negative 64, so we're going to put that next to the x, and then c is 200. All right? And there's the equation of the curve of best fit for this set of data. All right? Then you are probably going to be asked to answer a question using that equation. By the way, if for some reason Desmos gives you A, B, and C in decimals, you will need to keep at least 3 of them. You can keep more, but no less. All right, so here's our question. It says, how many seconds will it take the tower to reach the ground? Well, you have to first interpret that in terms of the problem. All right, so remember the problem was given as a time and a height. All right, and so, all right, the question is how many seconds. So it wants us to find a time, all right, which remember we called x. So it wants us to find an x. And it says when the tower will reach the ground. Well, what's the height on the ground? All right, what's the height on the ground? 0. And so that's y equals 0. All right, so look what that's asking me to do. That's asking me to plug in 0 for y into the equation I just got and solve for x. And solve for x. Plug in 0 for y, solve for x. All right, well, technically we should factor and, you know, take out GCF and all that stuff. But I'm going to let you use Desmos to solve that as well. Okay, I'm going to let you use Desmos to solve that as well. So here's what you do. You literally type that equation in Desmos. It doesn't matter which side you put the equal 0 on. So if I want to do 0 equals, that's fine. Negative 16 x squared minus 64 x plus 20. And what you should see is that on the graph, you now have this vertical line. All right, you now have this vertical line. No, that's not what I want. Did it keep the equal 0? Why didn't that work? Oh, because it's not 20, it's 200. Huh. Okay. Man, I am really struggling here. I probably should just stop the video and start over, but I'm not going to do it. I'm 15 minutes in. All right, so it's equal to 200. And so you should see this line on your graph, all right? And it should intersect the original curve at the x-axis, okay? And that black dot, the x value of that black dot is the solution to this curve, or to this equation. All right? Now let me see. There is a second point on the negative, like on the x-axis in the negative direction, but you have to remember that your question was asking about time, and time can never be negative. So that answer does not make sense for this problem, okay? And so I only want the positive time, all right? And so that would be the answer to our question. All right, let's try another one, make sure we get the hang of it. All right, so I'm going to give you some new information. Braden jumped off a cliff. Woo. All right, so I don't need this anymore. All right, now I'm actually going to be lazy, and I'm going to leave this one typed in. I'm just going to turn them off, okay? And I'm going to edit my table. All right, so Braden jumped off a cliff and into the ocean while vacationing in Hawaii. His height, h, after time t seconds is given in the table below. So we have time and height again, all right? And you have to remember that that's an x and a y when you type it in your table. So let's type in all the times. Nope, sorry. What in the world? Okay, sorry, I gotta go over here. All right, let's type in 0, 1, 2, 3, 4. Oh, I want to delete all of these. Sorry. I really didn't think I was going to have to do it that way, but that's okay. All right, 0, 1, 2, 3, 4, and then 480, 482, 452, 390, and 296. What did I do? Man, 480, 482, 452, 390, 296, and that's not a thing. Okay, so there we go. So we have a shape, all right, we have some, and we can hit the plus sign and it'll fit it on there better. And you can kind of see that there's a curve to that, okay? So a little bit of a curve to that. And so we have to decide which shape is better. And so remember, I already have this typed in. If you don't, you need to type it in again. y1 tilde ax1 squared plus bx1 plus c. And if I click on the circle next to it and turn it back on, you can see that that lines up really nicely with my points. Lines up really nicely with my points. If I want to check the other one, let's turn that one off and turn the other one back on. Oh, that doesn't line up at all. So that one's definitely not the right one. Let's turn this one back on. Okay, and now we can write down the equation using the values that they gave me right in Desmos. So I'm going to say y equals negative 16x squared plus 18x plus 480. I'm literally using the a, b, and c right here, okay? Then I can use that equation to answer the question. How long will it take Braden to reach a height of 150 feet? Okay, well, height is a y value. The question, how long, is an x value. So again, they're asking me to plug in 150 for the y value and figure out what the x value is. Now, without Desmos, that means we would have to make it equal to 0 and factor and all that stuff, but you don't need to bother. What you need to do is come over here to Desmos and type in 150 equals negative 16 x squared plus 18x plus 480. I think I got it in there right. All right, and then I might have to adjust my curve a little bit. All right, because what I really want to find is where do these two, since it doesn't say equal 0, I'm not looking for the x-axis. I'm really looking for where the point intersects the parabola. Where does the blue line that just showed up, let me shift that around a little bit. Where does the blue line that just showed up intersect the red graph that I had to start with? Okay, and the answer is the x value right here. Okay, the answer is the x value. And so that means it takes 5.139 seconds to reach a height of 150 feet. Okay. All right, now just got two more. All right, this next one says the table to the right shows the year and population in millions of Texas. The year and population of Texas, yeah. Sorry, and I want to write an equation for the curve of best fit and then estimate the population in 2020. Okay, so let me slide over here. Now, this is what I have a special note of on the front of the page. It says if the information is given in years, you need to convert the years, all right, by making whatever the first one is they give you, you need to make it 0. All right, and then you need to go from there. So these are your x values. All right, well, how many years apart are 1900 and 1920? They are 20 years apart. Then how far apart are 1900 and 1940? They are 40. All right, 1900 and 1960, and then 1900 and 1980. Okay, and so these are going to be your x values, and the population is going to be your y values. All right, so we don't need the equation. Let's turn off this graph, but I'm going to be lazy and not type it again. But I do need to delete all of these. Not that. Okay, so my first one is 0, 20, 40, 60, 80. And then over here, 3.1, 4.6, 6.4, 0.5, 14.2. And then remember, you want to hit this little magnifying glass. Okay, there we go. Now, our shape is very different this time. So I'm going to do two things. I'm going to click on the quadratic. That lines up pretty good. And then I'm going to click on the exponential. They actually both line up really, really well, okay? Because I'm only talking about through the points. I don't care what happens before those points or after those points. I want to know what happens through those points. And they're both very, very close, okay? They're both very, very close. So what you need to do is, okay, so what you need to do is look at this r squared value, and and you need to have log mode there. All right, so you need to look at this r squared value. Sorry, that's on the front on the notes. If it's exponential, you have to click on this log mode button. You look at this r squared value, and whichever one is closer to 1 is the better curve. Whichever r squared value is closer to 1, all right, is the better curve. And 0.999 is closer to 1 than 0.997. All right, so I'm going to turn off my quadratic, and I'm going to go with the exponential. Okay, so what am I going to write over here? Well, remember the exponential, the standard form looked like this, a times bx. So that's why they gave you an a value and a b value right here. So we're going to write y equals, and we have decimals. So we have to round to 3 decimal places or more for a, and 3 decimal places or more for b. Just don't forget to put the x. All right, so there's my equation, but then instead of asking like a part A and a part B, I just went ahead and said, okay, now estimate the population of Texas in 2020. Well, 2020 is a year, right? 2020 is a year, all right? And so I have to put it in terms of the same type of numbers I used in my table. So I have to figure out how many years is it from 1900 to 2020? And that's what X I'm going to get to use. That's the X I'm going to get to use. So I'm going to come over here and I'm putting 120 in place of the X. All right, so in my line over here, I'm going to type in 3.095 parenthesis 1.019 parenthesis raised to the 120. And the Y, the answer, is the 29.618, right? But another thing you have to be careful of is that you interpret this in terms of the problem. So is the population 29.618 people? No, it's 29.618 million people. All right, so sometimes you have to read back and look at the rest of the problem. All right, sorry about that. Okay, and then last but not least, all right, I have another one. Mike deposited $1,000 into a savings account. Over 5 years, the account has grown exponentially. So this one actually gave you a keyword as shown in the table below. Assuming the rate of growth continues to be the same, write an equation for the curve of best fit, then predict the amount of money Mike will have after 10 years. Okay, so this problem, there's not going to be any guessing whether it's quadratic or exponential. It's going to definitely be exponential. So make sure that you don't even turn on the quadratic one. All right, we have to also decide, and it does matter, okay? You can't just randomly decide. Your years are definitely going to have to be your X, and your money is definitely going to have to be your Y. And then we're going to come over here. We're going to delete all this stuff. Oops. Okay, and then we're going to put in our years. 0, 1, 2, 3, 4, 5. And then we're going to put in our money. 1,000, 1,061.80, 1,027.50, 11,097.20, 71.20. Whoop, don't forget your decimal point. And 13.49. Is it again? Sorry. 13.49.90. And then hit your magnifying glass. Okay, and so it's going to zoom in on the points, okay? And so you can just see the points, but remember it told us that it was exponential, so you want to make sure that you have that one turned on. You can see that r squared equals 1, so it's a perfect fit, okay? And then it gives you an a value and a b value. So when you come back over here, all right, remember how you have to write it. Y equals the a number with at least 3 decimal places times the b number with at least 3 decimal places. You can keep more or you can round, all right? Raise to the x. All right, then the question says, then predict the amount of money Mike will have after 10 years. All right, well, years is an x value, all right? And so they're telling me to plug in 10 for x. So I want you to write it down so you can show what you're doing. Plug in 10 for x and then get an answer. And that is something that you can do in Desmos or any other calculator. We want to raise it to the 10th. All right. And then last but not least, when you write down the answer, usually you are going to round to 3 places. But in this case, the answer is money, right? This is how much money he has in his account. So you can only keep 2 decimal places. All right, so that's one of the little details that you have to pay attention to. Okay, so quick recap. You're going to be making a table in Desmos by clicking on the plus sign, okay? And when you do that, you're going to add a table. All right, once you have it, you're going to put in the X and the Y values. And if I were you, I would go ahead and type y1 tilde ax1 squared plus bx1 plus c in one line, and y1 tilde a times b raised to the x1 in the other box, and make sure you click log mode. Make sure you click that, okay? And then what I would do is once you type in the information for your table, check one of these at a time by clicking on the circles and seeing which one lines up better. Now, real quick, this last one, both of them line up extremely well, but that's why it's important to read the problem, because if they tell you it's exponential, all right, you have to use the exponential one, okay? All right, and then of course, make sure you answer the final question and label it with the appropriate units. All right, and that is it for our last lesson in Unit 8. Hopefully you don't feel like that's too bad. I know it takes a little while to explain it, but doing the work isn't too bad. So you'll have a little worksheet with a couple problems on it to practice on your own. And I'll see you next time.